Okay, here are some radical equations, and we're told to solve these things and figure out what the variable is. You've solved equations before from the polynomials unit. They didn't have radical signs in them, and the presence of this radical sign here is going to introduce a few new things that we have to be careful of. And I'll talk about those as we get going. I think the best thing to do with solving these is just go through the motions of how we solve them. So I'm going to start with 6 minus 6 5 omega minus 4 equals negative 2. Okay, there's my equation. And when you're trying to get at omega, okay, this is a bit like peeling off layers of an onion. Everything that's complicating this is all this stuff around the omega, right? We've got a times 5, we've got a minus 4, and those are all inside a radical sign. And then outside that, you've got a times 6, you've got a plus 6. So start as far away from omega as you can, generally, and just start doing some inverse operations. So while this is a plus 6, I'm going to do a minus 6 to get rid of it. And now we have minus 6 times 5 omega minus 4 equals negative 8. And now I want to get rid of that negative 6 times. So I'm going to do the inverse of multiplication. That's division. Okay, so I have divide by negative 6 on each side. That leaves me with 5 omega minus 4 equals 4/3. Now, what do we keep doing here along the lines of inverse operations? The inverses of addition and multiplication were clear. You may not remember, but the way you do an inverse operation with the square root sign is to square it, right? Exponents cancel out radical signs. They're inverses of each other. And if I square the left, I'm going to have to square the right too. So we square both sides. That's going to cancel out the exponent and the radical sign. And what's left is the thing under the radical, the radicand, 5 omega minus 4 equals, in this case, it's 16/9. Okay, and now we keep on going like we were solving a regular equation. It's going to be 5 omega equals 16/9 plus 4. But instead of 4, I'm just going to write 36/9 because that'll make this a little easier to deal with. That's 52/9. And now I have to divide each side by 5. So this is going to become omega equals, well, 52/9 divided by 5 is the same as 52/9 times 1/5, right? And that, in turn, equals 52/9 times 5 is 45. So there's our solution to the first one. And now let's come down here and grab this next equation and solve that. It's going to be similar techniques. It's a coincidence that it's 5 delta minus 4 in the radicand. It's kind of funny. So let's go ahead and write the equation here. The big difference here is that it's a cubed root. And you'll see how that comes into play. You may be able to figure that out on your own. If you want to pause the video, go ahead, see if you can solve this. I'm going to subtract 6 from each side. We're going to move a little quicker here because you just saw me do everything before this. And now I divide each side by 3. Negative 1 equals cubed root of 5 delta minus 4. And now, instead of squaring both sides, going to do something different. We are going to cube each side, because cubing is the inverse of a cube root. Okay, that 3 in the exponent cancels out the 3 radical sign. So what we get is, on this side, we get 5 delta minus 4. And on the left, negative 1 to the third power is just negative 1. If you count them up, the negative stays. And add 4 to each side, you get 3 equals 5 delta. And there we are at the end. Delta equals 3/5.